We're getting near the end of our course now. We have just 2 chapters left to cover. Both of them have to do with pointers. Chapter 18 is called Advanced Pointers. Chapter 19, I guess you could call that Advanced Pointers, but I'm actually going to call it Function Pointers. Let's have a look first at Advanced Pointers. First of all, we'll start off with a couple of simple concepts, such as what we call the void pointer. Let's have a look at the following code. Imagine you created 2 arrays. Well, they're not really arrays, but they're treated as arrays. We've got, say, 10 integers and 10 floats. Each one of them comes from malloc, so it comes from the heap. And then you want to create a function that will free up each of the memory associated with those 2 variables. The question is, can you do it? Is it possible to write a function that will take both a pointer to an integer and a pointer to a float as its sole parameter? More to the point, what would you say would be the return type of the function called malloc? Does malloc return a pointer to an integer, or does it return a pointer to a float, or does it return something else? So there's the question. What should be the type of the parameter to free it, the first and only parameter? Well, it's actually possible to declare a pointer to anything as follows. This is what we call a void pointer. It's a pointer to what? It's not a pointer to an integer or a float, it's a pointer to a void. A void's not really a data type. In fact, you can think of it as a non-data type. Nevertheless, we can declare a pointer to one of these things. And that can be, if you like, the type of the parameter to free it, and the return type of the function malloc. And this is why. Because no compiler errors or warnings will be generated when using this particular type of pointer, a void pointer, in an assignment statement or in parameter passing. If you want to use it in an assignment statement or in a parameter passment with any other type of pointer, you will just simply not get an error message or a warning. That means if you had a pointer to an integer a and a pointer to a void b, it would be possible to say a equals b or b equals a, and the compiler would not complain about that. So these are used quite commonly. They're used by malloc and free, memcopy and memset, and basically any function that uses memory in a generic way. It's not tied down to one particular type of memory. For example, malloc and free, they don't care what type of memory they are providing. They don't care if you want to point it to an integer or point it to a char or point it to a structure or anything else. And so they are perfect candidates for using these generic pointers or void pointers, pointers to anything. Call them what you will. There's just a couple of things to keep in mind when using void pointers. Size of the contents of the pointer, in other words, the thing that the pointer points to, try and take the size of that, you can't do it. You may not get a compiler error message, or you may, but it's simply undefined. Don't try and do it. Similarly, the actual expression, the thing that the pointer points to, is undefined. You'll probably get some kind of compiler message out of that. The reason being is we simply don't know how big the thing that pointer points to is. It obviously points to an area of memory, but what are you supposed to interpret that memory as? Are you supposed to interpret it as an integer, or a series of floats, or a collection of chars, or a few structures? You just simply don't know what it's pointing to, and so functions like printf or assignment statements or anything, they simply cannot interpret the object at the address that pointer points to. If you have a void pointer and you need to use it in some way, you need to actually dereference it, which means you need to use the object at that address, then create a second pointer. The second pointer would be a non-void pointer, and then simply assign the address in the void pointer to the address in the non-void pointer, and then continue to use the non-void pointer, like so. Create, say, a pointer to an employee. You can think of that as a pointer to an employee. You can even think of it as an array of employees, depending on how much memory is set aside in the void pointer. Let's have a look at some examples of void pointers. This is void.c in the Chapter 18 folder, and this is what the focus of this particular function is all about. This particular program is focused on this function, the memdupe we simply want to have our own sort of generic memory function. What it will do is it will take the address, take an address of some piece of memory, and the size of the area of memory set aside at that address, and it will simply duplicate it. And then it will copy the memory that's in there into the new place. So we create a new pointer, we assign that to malloc, so malloc goes and gets that amount of memory. Then once that has succeeded, we simply copy the contents of the old memory into the contents of the new memory using the memcopy function. There is a standard C library function called memcopy, and that's exactly how it works. You give it, it's a bit like strcpy. You give it a where you want the memory to go to, where you want the memory to come from, and how much memory there is, and it will simply copy from one to the other. When we're done, we return the new pointer. Now, the interesting thing about this is that the return value of memdup is a void pointer, and the first parameter to memdup is a void pointer. Malloc's return type is also a void pointer, and the two first parameters to memcopy are also void pointers. So we've written quite a generic piece of functionality here that could be used over and over again in just about any circumstance. Just in case you're interested, you could have done that all in one line if you'd done it like that. You wouldn't have needed a separate pointer. I just wrote it out like that to make it more clear. However, that line highlighted there would have done exactly the same thing. So let's see where and how we might use such a function. If I've got an array of floats, an array of integers, an array of chars, all initialized, I can theoretically copy them using my new memdup function into 3 new pointers, like so. Now, hopefully, if the void pointer does what we think it's going to do, in other words, not cause any compiler warnings or compiler error messages, then this will compile cleanly, and it will probably even work. I don't actually bother to test whether it works. I'm going to assert that if it compiles, then it probably works. So we'll just simply free up the memory and close. So let's see if it does actually compile. And we get 0 errors. Okay, so that's all I wanted to show you about void pointers. I just wanted to show you their use. We'll be using void pointers quite frequently from now until the end of the course.